Yes, thanks a lot for the introduction and also the opportunity to speak at this very prestigious event. My name is Bernt Skeie, and I was born and raised in the fjord country in the western part of Norway. So between the steep mountains and the fjord, the water, there's little room for roads. So the natural way to transport both people and goods is actually on the water. So herein lies the maritime DNA that have made Norway a front runner in shipping. Also, these fjords are now pushing the development of green shipping through zero-emission regulations in our World Heritage fjords. Yeah, my talk today will focus on tech transfer, how technology developed for space actually finds applications on Mother Earth. But first, I'd like to give a brief introduction to Prototech. Prototech is based on an engineering and technology tradition dating back to 1930, when CMI was established as a non-profit R&D institute. Prototech was established as a separate legal entity in 1988 and was part of the Christian Michelsen Research group for 3 decades. Our aim is to develop profitable technologies which will positively impact our planet through prototyping and also energy systems for space and ocean space. In June this year, Aker ASA acquired 100% ownership of Prototech. Aker combines an entrepreneurial spirit with 180 years of industrial history, which fits well with Prototech DNA and our ambitions for the future. Aker has a total turnover of more than 75 billion NOK and a workforce of approximately 28,000 people. So for Prototech, the change of ownership is a natural step to realize our full potential and to make a real difference in the zero-carbon economy. Prototech has worked closely with the Norwegian and European Space Agency for decades, and we have more than 30 years experience now from hydrogen and fuel cell technology. So to the left here, you can see some examples of components for space, and to the right, we have a picture of a small passenger vessel that we had running on hydrogen in the harbor of Bergen more than 10 years ago. Some more examples of what we do can be found on this timeline right here. The 1991 Mjølner project was actually a project where Prototech developed the first ever planar solid oxide fuel cell system. It was done for Statoil. But from then until 2014, most of the development was related to energy systems for space. Since I joined in 2013, our focus has been to find terrestrial applications for our innovations. And our slogan soon became "From Space to the Seven Seas." I will mention some of these applications in a few minutes, but before we move on, I would also like to say a few more words on space. As I said, Proto has a long history from space. Here, illustrated by Odd Dahl, working on the payload instrument to be launched by Ferdinand 1. Odd was a pioneer in Norwegian space history and the founding father of both Prototech and CERN. Here, the second picture is actually from the launch of Ferdinand 1, the first rocket from Norwegian soil, I guess, in Andøya Spaceport in 1962. A little later, some years later, we got to play with bigger rockets, developing the gimbal joint for Ariane 5. And currently, we're also working on hardware towards space. We are delivering hydrophobic filters to the Orion spacecraft, which will bring humans to the Moon and Mars in the coming years. Here are some examples of ongoing space projects aimed at Mars and the Moon. We are particularly proud of the Lunar Night Survival Project, where we are prime and Airbus and Air Liquide are our subcontractors. The aim is to develop energy and heat for the lander to survive 14 days at temperatures down to 190 degrees below Celsius. So our regenerative fuel cell systems, the RFCS, it's a closed-loop system in which solar power is used to split water into hydrogen and oxygen through electrolysis. When the system enters then the shade and the solar power no longer is available, the process is reversed and hydrogen and oxygen is fed into a fuel cell to produce power and water. So it's a very efficient way of storing energy and has a much lower mass than batteries. The aim is actually to be at around 20% of the batteries available today. We are also developing high-temperature solid oxide fuel cells and electrolyzers for Mars applications. Illustrated on the right here. The beauty of solid oxide fuel cells is its fuel flexibility and the ability to use in situ resources. We have also previously developed a methane recovery unit for a manned flight to Mars, which has found some very interesting applications now within sea farming. In the Lunar Night project, we have designed a very compact breadboard with 4 different compartments for the electrolyzer, the fuel cell, the water tank, and also for the interface. It consists of more than 2,000 unique parts, many of them machined in our own specialized workshop. This is what it looks like in real life. These pictures are taken in our energy lab in Bergen just a few days ago, when testing has just begun. I have included just a few pictures, some hardware being developed for the Moon and Mars. This is then an engineering model of a regenerative fuel cell system for Mars and also a high-pressure water electrolyzer, which is something we are delivering within the next couple of years. This is also from our energy lab. This is a test setup for stack testing at 850 degrees and at 10 bars. So there is a lot going on in our energy lab at the moment. But the question arises, of course, where is this technology relevant? Well, where energy prices are high and where quality is of great importance, such as in the ocean space. The RFCS will be used for offshore wind to reduce emissions from offshore rigs. The solid oxide fuel cell technology is ideal for deep sea shipping. And our microwave-assisted pyrolysis reactor, the methane reactor, with gasification that we have now, will reduce emissions and waste from sea farming going forward. But offshore gas turbines are actually responsible for more than 2/3 of CO2 emissions on the Norwegian continental shelf, and almost 30% of Norway's total CO2 emissions. So we started there. The technology we developed was called CHEOP, Clean, Highly Efficient Offshore Power, and the idea behind it was to replace offshore gas turbines. In our design, we combined then solid oxide fuel cells and high-temperature PEM to keep it compact and to reduce weight and footprint. Key features here is the high efficiency, the fuel flexibility, it's modular by design, and low maintenance, not so many moving parts. The technology is a combination of high temperature and low temperature fuel cells and a palladium separation membrane. There is also heat integration between fuel cells, reforming and steam generation, and oxy-fuel combustion is included for CCS. Oh, it moved on. Here we go. The technology then is also very suitable for combination with batteries. The funding, you can see, was from the Research Council and Gassnova, and our partners in this starting out was Statoil and Shell. Also, Reinertsen is delivering this palladium membrane. The next one. So where else is this technology relevant? Well, the answer can be seen here. It's deep sea shipping. For short sea, all the red areas here, you can see that if there's high regularity and the low distance, then battery and hydrogen will work well. But for transatlantic or Pacific crossings, you need alternative solutions. And maritime transportation is, of course, one of the largest polluters globally, approximately 3% of all total emissions of greenhouse gases today, and as much as 12-13% of SOx and NOx. And the reason why this is we are pushing this now is that IMO regulations require a reduction in total annual emissions to reduce by 50% by 2050. And this is at a time where also the need for transport is growing. So they can't do step changes, they really need big changes. And that's what this technology offers. The drivers behind clean shipping are the following. It's the consumer demand, actually, the carbon taxes, important, and the cost reduction of hydrogen and ammonia, which is very much talked about now in maritime circles, and the fact that also these clean machines or engines are becoming available. DNV, in their maritime forecast, they expect clean fuels to play an important role going forward. In the maritime forecast, as said, they expect ammonia and LNG to make up as much as 60% of the fuel mix in 2050. You can also see that the hydrogen bit is almost not visible in this picture. It's 1%. So you need technology that can actually chew both LNG and ammonia. And that's the beauty of high-temperature fuel cells. Many ship owners today are trying to pick the fuel of the future. But of course, we are of the opinion that you should rather pick the engine. And these are the alternatives. It's batteries, proton exchange membrane, PEM cells, internal combustion engines, made for then also dual fuel for ammonia and LNG, and also solid oxide fuel cells. And for deep sea, batteries are really not applicable. PEM have some challenges related both to infrastructure and cost, but while fuel slip and also let me see, pilot fuel. There's a lot of pilot fuel used in these internal combustion engines, makes them less desirable. They are the less desirable size of combustion engines. Solid oxide fuel cells is quite costly and still under development, but the winner for deep sea, at least in my book. We are currently working on 2 large demonstration projects. Ship FC, Clean Ammonia Power, is an EU-funded project where Viking Energy, owned and operated by Eidesvik, on a long-term contract for Equinor, will have a 2 megawatt clean power unit retrofitted. The system shall be demonstrated in commercial operation for at least 1 year and 3,000 hours annually. The ammonia fuel cell system will be installed in Viking Energy in 2023, and this is the first time an ammonia-powered fuel cell will be installed on a vessel. To the right, you have the KEOP CC. It's an installation of a 1.2 megawatt auxiliary power unit on an Odfjell chemical tanker. Development based on Clean Power Phase 2 R&D program. I showed you the KEOP's concept, and with joint developments then with Wärtsilä and Odfjell. The other partners also can be seen below these pictures. All these systems will be tested at the Future Fuel Test Center, Energy House, Stord, south of Bergen. It was recently opened by the Prime Minister, Erna Solberg, and the center is then part of the Sustainable Energy Catapult, and which will also play an important role in testing of offshore wind and other technologies going forward. We had the proper distance, you can see there with the Prime Minister. It's good, Corona time. The selling points of clean power, these units, of course, is the emission-free operation on ammonia, hydrogen, or LNG, or methanol with CO2 capture, up to 70% electrical efficiency using high-temperature fuel cell technologies. It's also, you've got the heat in many cases, if you can use that for hotel load. It's modularized, adapted and improved for marine applications, and scalable to multi-megawatts installations over time. Optimized and adapted for marine use, as I said, improved space utilization and flexibility in ship design. And it has few moving parts. There's no oil change, very limited maintenance, which should give a long service life. And in sum, you reduce total cost of ownership for the end user through fuel and tax savings, carbon taxes coming up as we see, and also the reduced maintenance. So, finally, a couple of words on Clean Power, the company. We have established Clean Power to commercialize this technology. A dedicated group of senior people will focus entirely on time to market to develop products and services in parallel with the demonstration projects. Focus will be on areas such as sourcing, manufacturing, life cycle cost analysis, as well as strategic cooperation with industry partners. And most importantly, we will apply the total skill set of the Aker Group to develop products and deliver services. Aker, on the other hand, intends to build its platform for breakthrough innovations on the shoulders of Prototech. A very structured approach to innovation, powered by Aker's capital, competence, and capacity, will surely boost commercialization of industrial technologies going forward. And so, to summarize, all the technologies I mentioned, Clean Power, Aditech is actually an additive manufacturing company, which we will set up to produce some of our parts for our own space programs, the high temperature cells. So it's also from space inspired in that sense. The RFCS and the MAP-G, microwave assisted. That is different. Pyrolysis with gasification is, all of these have one thing in common, and it's actually that they originated in space. So I started my presentation with a picture of water, a Norwegian fjord, and I will also end with water, but this time it's ocean space seen from space. Thank you for listening.